Okay, so today we are going to work on 1.6, represent functions as rules and tables. We are going to have a few things that we are going to glue into our notebooks, but we do not take time out of class to glue in our notebooks. I'll show you what to write in our spiral notebook. I'll give you the sheet, and you guys can fill it out with me as we go. But part of your assignment, I'll put in here, is to glue them into your notebook. It's a very easy assignment. I have glue sticks in here, so if you need to do it on my bed, that's great. Okay, but we're not going to stop class. We're just going to do our instruction. Warm-up activity. So check to see if you guys did this right. I'm going to go ahead and just give you the answers. Write an expression. 7 more than a number x. So I'm going to say x plus 7. Determine if 3 is a solution. So the question is, yes or no? Is it a solution? Meaning, does it solve the problem? And, so 3 goes in for x. 2 times 3 minus 4 equals 2. 2 times 3 is 6. 6 minus 4 is 2. So my answer is yes. Number 3, George spent $4 more than twice as much as Casey at the store. Gentlemen, why don't you guys come up here? If George spent $4 more than twice as much as Casey at the store, if Casey spent $6, how much did George spend? We're going to write our equation out. He spent 4 more than, okay, so I'm going to do plus 4. Let's see. Twice as much as Casey, and Casey spent 6. So then I'd have 6 times 2. I find my answer. 6 times 2 is 12. 12 plus 4 is $16. Alright, today we are, like I said, working on representing functions as rules and tables. Our learning goal, I can understand functions and I can use models to understand relationships. The first thing I'm going to hand out to all of you will go into our spiral notebook. This is one of those Freyer models. Like I just said, we will fill this out together. It is your job to do it. So you give Alex one when it gets to the back, and you guys give Will one when it gets to the back. Okay, in the middle of our Freyer model, the first thing we are going to write is function. And the definition of a function is a set of pairs of input. This is important. Input is your domain. Output is your range. You're going to see those words a lot today. So a set of pairs of input and output values where every input has exactly one output. That is extremely important to be a function. One input goes to one output. If an input goes to more than one output, we can graph it, but it is not a function. Okay, characteristics. This is going to be important. So what does a function look like? I'm going to type in there. And I'm going to say one of the rules of a function to identify if something I graphed is a function, we're going to do the pencil test. And the pencil test states, I'm going to try and simplify it so you're writing as least amount of words as I can. So I'll abbreviate it and then I'll explain it to you. But the pencil test, draw a vertical line through the graph, and if it touches the graph in more than one place, it is not a function. This will make sense, and this is why we like the Freyer model. This is going to make more sense when we do our example and our non-example. So the pencil test states, if I draw a straight line and it touches any 2 points of a graph, then it is not a function. I'm going to go ahead and go to my non-examples first. So I'm going to draw this grid. I'm going to draw my grid like this. And when I go to make my little lines, I'm going to make it like this. So this is what I graph. And I use these coordinates to graph. So if we ever get a graph, you can do it in here or in your room. If I look at this graph, my pencil test is saying if I take a straight line, the pencil, and I put it so it goes up and down, like this, and I do this, notice how it touches a spot here and here. It touched my graph twice. That's not a function. So it's only a function if it goes through once. I'm going to draw a real example to show you. On this one, that green line, that is our graph. And I can put my coordinate points on here if I want. See how it's a straight line? If I was to put a pencil straight up and down, and I went across that graph, it only crossed that line one place at a time. It would never cross that green line twice at the same time. When it's touching right here, it's not touching any other place on my line. Where on this side, I'm going to erase that. But on this one, when it touches here, it's also touching here. That's no. The other example is how we can tell if it's a function right away. To tell quickly if it's a function, one, when I give you your coordinates, notice how my domain, these are your domain, this is your range. We have another sheet that's going to help us with that. That my x-coordinate, that domain, that first coordinate only goes to one and only one number. It does not go to anything else. Need to test. Okay? The other way we can look at it, so right away, if you ever look at your coordinates and you go, okay, 1 only goes to 3, 2 only goes, let's do the non-example of that. A non-example would look like, okay, 1 went to 3, 2 went to 3, 2 went to 4, 3 goes to 5. We see this is not a function because my 2 went to 2 different places. And I'm going to draw this one real quick. You can put it in if you like. But instead of just coordinates, we see it as an input-output box. So it might have looked like this. It's just a table. So they have X, Y, and then they had 1, 3, 2, 3, 2, 4, 3, 5. It's the same thing. Right here, the 2 went to 3, and the 2 is also out of 4. Okay. 2 more little graphs I want to show that we can draw. If I have this, so we have that straight line. Remember, the straight line could be going that way, or the straight line could be going, I'll use a different color. The straight line could have been going that way on that graph. We could also do this horseshoe shape. As long as these lines right here are not straight up and down, they work. So as long as they're curved at a little bit of an angle, it will work. Because that pencil test, it won't cross the line more than one spot. Over here, non-example, especially if we have something like an S, because it's going to touch more than one spot. And the last one I want to show you, if it's these coordinate points, even if there's not a line on them, this is not going to work. And the reasoning is, you can see that right here, those two are right above each other. If they're on the same Y coordinate or the same X coordinate, they will not work. Okay, so you're going to glue that in your notebook. I will help us and show us exactly what that should look like in a second. This sheet won't take us very long. We'll glue this one also in our notebook. Remember, the reason we use these foldables is so when you go to study, you can look at them and it's a quick, easy review about the main ideas of how. Okay, what this is, it's the abbreviation. The most important thing I would say is look at it like this is your coordinates. Okay? I'm showing that these are two separate things, but they all go together. Because when I give you things like 0, 3, 1, 5, 2, 7. Your first numbers are going to be DIX. And what that is going to stand for is 3 different names it's known as. We either call it your domain. And today, they're going to give you tables and say the domains are 1, 2, and 3. They just told you 3 of your X coordinates. Or, if it's in a table, zero, 1, 2, they call it the input. So 0, 1, and 2 are your input numbers. Or they are your X coordinates. When you go to graph something, the numbers along this going left to right is your X x coordinates. When I look at a graph, I go left to right, that's my x coordinate. The ROW are the three names that the y one gets. First one, and you can see this a lot today, is range. Range means list all of those second numbers. The 3, the 5, the 7. It's also your output. So in a table, the 3, the 5, the 7, they're your output because 0 went in, 3 came out. 1 went in, 5 came out. 2 went in, 7 came out. Okay. Or it is your y coordinate, which is the ones that go up and down on your graph. Last handout to give you. So we have three things that we're going to glue in our notebook that should help us the most. Really short. Did I count wrong? Oh. And I'll get you a calculator. Alright, so here's what we're going to do. Everyone is the top left ordered pairs. Let's write those ordered pairs down. So we're writing down 0, 5, 1, 2, 2, 2, 4, 1. When they ask us to do an ordered pair, that's like this. These are our coordinates. They put parentheses around it and a comma between them. The one on the left of the comma is our x coordinate, our domain, our input. All three of the same names. The second one is our y, output, range. So I see I have 4, 1. We can also take our coordinates and put them in a table. So I would go x, and I can do it either way. My table can go left to right or up and down. If I do this, x, y, and then I just say, okay, 0 to 5, 1 to 2, 2 to 2, 4 to 1. The nice thing is when you use a table, it's very easy to see your domain and your range. My domain is my x coordinates. My domain is 0, 1, 2, 4. My range, 5, 2, 2, 1. Sometimes they're going to ask you to do something called a mapping diagram. The mapping diagram is very easy. I take my domain, and it's in a circle, and in this circle I have the ranges in. The nice thing is they don't have to be in order, by the way. Like it might be 2, 1, 2, 5, but then you're drawing lines to connect into where they go. Okay, so 0 was 2, a 1 was 2, a 2 was 2, a 4 was 1. The nice thing about that is I really didn't have to have this just 2 in here. But then I can see something right away. Is this a function? You can see that right away. Because what happened? Right here. 2 numbers came to it. So what we've just done, is this going to be a function? No. We can map it. It's coordinates, yeah. But it's not a function. And then we graph it. Okay, 0. So 0 here, and then we go 5 up. 1, 2, 3, 4, 5. 1 over 2. 1 over 2 up. 2 over 2 up. 4, 1. 1, 2, 3, 4. And then we graph it. And as I already highlighted, here's our domain and our range, which I already used off that x coordinate. The domain was 1, 0, 1, 2, 4, and the range was 5, 2, 2, 1. Okay, we have just about a minute or 2 left. Last thing I'm going to cover, and then I will record extra. Remember I told you when we're not ready in the beginning, it takes too much for our class time. But we have a couple other problems that I'll do. A couple important parts for you to see. Is it a pairing? Is this paired a function? Right away we should say no, because these 2 go to different numbers. So that one's easy, no. The rest of your assignment, what you're doing is you're going to do the domain of the function is, okay, so they took you this keyword. Domain is here. So I know right here it is 0, 1, 2, and 3. They told me your domain is 0, 1, 2, 3. So I go to my x coordinate 0, 1, 2, 3. To find my y, I just have to solve each time for this. 3 times x. Well, I'm going to put x as 0. So 3 times 0 is 0. Okay, for the 1. 3 times 1 is, okay, for the 2. 3 times 2 is, and then the last one is 9. It's going to ask you the range. You still say 0, 3, 6, 9. Alright, listen up. I'm going to do 2 things for you. 1, I will finish recording this, and I'll put the link up on our notebook. I also have a second link to that video for you that's talking about how you can always find the rule to any function. Your homework, everyone listen, by Monday, your homework is, it's listed, I'll put it on Schoology, it's here, it's on my board. Page 38 through 40 in your notebook, in your textbook, numbers 4 through 20, and number 28. If you want to do it on blank paper and bring it, you can. If you want to click on A4's homework and do it here, you can. It's listed in OneNote. It's listed here. It's listed at the end of our lesson. It's on Schoology, and it's on the board. Due by Monday. I will upload videos to help you.